Now in this part we'll talk about the derivative, since we need it in physics. So we begin with the function limits in order to talk about derivative. What is a derivative? It characterizes the rate of change. When we say the rate of change, it's the same thing as saying the rate of variation. So we have a variation of what? A variation of the function. So if we want to write it, it's symbolized or it's noted by, this is its notation, f prime or df over dx. This prime, which symbolizes the derivative, is the same as derivative of f with respect to x. So it's the same thing. Now, it's given by its definition by, we've said that it's a rate of change of the function. So we notice this is a variation. This is what we call rate of change. It's a variation. But we notice here that it's a very, very small variation. So this is why we included limit. So it's limits, instead of saying delta f over delta x, in order to have a very small interval, we included limit when x tends to x0. This is the same as saying limit when delta x tends to 0. Means we are taking a very small interval of x. So in this case, this very small interval of x with the delta will give us this df over dx. And this is what you call an elementary interval, which is the definition of the derivative. This means df over dx is the same as f prime. In order to calculate now f prime, we have rules. We must apply the rules. But what does the derivative mean graphically? So here we'll have its interpretation graphically. If you notice here, we've taken a curve with a line intersecting this curve at 2 points. So first is the point A, having coordinate xa and ya. Second, point B, having coordinate xb and yb. And we notice that we have an interval. It's not small. We have an interval delta x. So in this case, if we want to find the slope of this line, what do we say? We say that slope equal yb minus ya over xb minus xa, and this is what we call delta y over delta x. So we have a big interval of x and a big interval of y. Now the question is, what will change to this equation to this slope, if instead of taking a big interval of x, we take a small interval of x? Small, this means we must take delta x tends to 0. This means b will become as if it's confounded with a. So what will happen? If in this case we add the condition, we notice that the slope, we will add this condition to the slope. Limit when delta x tends to 0. So what will happen to the slope? It will be equal limit when delta x tends to 0 delta y over delta x, and this is what you call together dy over dx. It's df over dx. It's the same as dy over dx. So this means we'll have what? We'll have f prime. So we notice that when we included this condition, the slope we have, which was the slope of the intersecting line, become in this case a derivative. So the slope equal to a derivative. This means the derivative graphically has a certain interpretation, which is the slope. But the question is, the slope of what? Is it the slope of the line intersecting AB or what? So if we notice what we did that we approach delta x to 0, then this means we don't have a big interval of time. Notice here, this means this part B become as if it's confounded with A. So the line which was intersecting AB become a tangent. A tangent at which point? At the point A. So this slope we found is not the slope of AB, since we approach the slope of the tangent. This means we know this means at the end f prime of x, or the derivative graphically, represent the slope of the tangent at this point. So a is equals to f prime. This means f prime, the derivative, is the slope of the tangent. This is graphically. Here we notice we will see this variation. So when it was a big variation, we had an intersecting line. When delta x tends approach to 0, this means the 2 points are confounded, the line become what? Become a tangent. This means the slope, which was the slope of this intersecting line, at the end, when approaching, it become the slope of the tangent. Now in this part we'll talk about the derivative as rules. So how to calculate the derivative. Here we have many rules. We'll talk about 3 rules, and the rest we have also examples. So if fx was equals to constant, then f prime of x is equals to 0. We take as example fx equal to 3, so this is a constant, then its derivative will be equal to 0. If fx was equal to ax, so this is here, a means it's constant, then f prime of x equals to a. Example, fx equal to x, so this is here, this is a. Then f prime of x equals to a, equal to 2. If fx is of the form ax to the power n, then its derivative will be n, so this is the power, times a times x and n minus 1. Then example, if fx equal to x to the power 3, so this is n here, and this is a, then its derivative will become n times a, so 3 times 2 times x to the power n minus 1, then 3 minus 1 is 2, so the answer will be 6x squared. Same thing for the others. So here you have many rules, and you have example for each one, and for the sine and cosine, same thing.